For number 16, we have to decide whether the product of two irrationals is always, sometimes, or never irrational and provide 4 examples. So let's take a look. Let's think of multiplying two irrational numbers. I'm going to pick roots. You could pick pi or other irrationals. So I'm going to choose, let's see, the square root of 2 times the square root of 5. So to multiply these two irrationals, I use one root symbol, and the product of the radicans goes on the inside, so 5 times 2 is 10. So if I had to classify this would be irrational because 10 is not a perfect square. So far, according to my example here, I would say that this is always irrational. But can you come up with the product of two roots that is going to be rational? Well, we need to pick two numbers that when you multiply them, you get a perfect square. If you can think of some, like 8 times 2 gives me the square root of 16, and the square root of 16 is 4. So in fact, we get a rational number here. So if they're asking us whether the product of two rationals is always irrational, it's definitely not. It could sometimes be irrational, or it could be rational. So sometimes we need to provide 2 more examples. So let's pick another one where we're going to get irrational, like the square root of 3 times the square root of 6. That would be the square root of 18. This would be irrational because 18 is not a perfect square. And then let's try to pick another one where we're going to get a rational number. Any time you multiply a root times itself, this is back to rationalizing, like square root of 3 times the square root of 3. Hopefully you agree that that's the square root of 9, which is just the number on the inside, a 3. So we get rational. So it's definitely sometimes it could be either or.